Take a look at the question on your screen. Pause the video, try to solve it on your own, check back in for the answer. Because this isn't an easy question. This is from the Purple Comet Math Meet. I think it's something like that. And it's question 21 out of 30, I believe. So it's not meant to be easy, but it's not meant to be super, super difficult either. But if you look at it, it certainly seems like it's very difficult, if not impossible. All we have is that A, B, and C are non-negative real numbers, right? That's going to be important later on. They satisfy this equality over here, this equation here. A plus B plus C is 400. And based on that, we have to figure out this value somehow. Okay, it doesn't look easy at all because there's oftentimes when you're doing maximum values, right, when you're optimizing or trying to find some edge cases, you might use geometry, right? That's one way to do it. You might use calculus. That's another way to do it, but it's going to be very difficult over here because there are multiple variables and it's going to be very ugly if you try anything like that. And the only other option we really have in most cases is inequalities, right? Is using the idea of an inequality. Now, geometry isn't going to work here. I don't know what this represents or what this represents or this geometrically. Calculus is not going to be easy either, so we'll have to think about inequalities. But to understand what we want to do, let's just look at this a little closer, right? What do you notice over here? Pause the video, think about it a little bit, look at it, see if you can do anything interesting with it. Now, we can't do anything interesting right away, but we can do some wishful thinking. We can wish that the square roots went away, right? Like we can just plop over a little 2 everywhere here, square them up, and now we have 2a plus b plus 2b plus c plus 2c plus a. And notice that we've got 2a and 1a, 2b and 1b, 2c and 1c. So adding this up, we just get 3 times a plus b plus c. What's a plus b plus c? Well, we're given this value. This is just 400. So this is 3 times 400 equals 1200. Unfortunately, though, it doesn't work that way because there is no square as much as we put it onto the paper. It's not actually going to be there, right? So we need to come up with a way to actually get those squares involved. How do we do that? Well, this might remind you of the Cauchy-Schwarz inequality, right? And now if you haven't seen it, it's not going to be a very fun video. So I recommend pausing it, searching it up and taking a look at it, or maybe I've got other videos as well. If I do, I'll try to put it up here so you can see it there. But essentially it states this, okay? And even if you don't know it right now, watch it over here. And I'm not going to prove it, obviously, right? This is just to solve the video, solve the question in the video. But this is what it states. Okay, so I'm going to put the statement over here. Then look at, and the condition I think is any real numbers. It's not just positive or non-negative. But anyway, I'm going to put it up here. Okay, just look at it, and then hopefully you'll be able to try it out on your own, even if it's your first time using it. Okay, and what it states is basically that the product of the sum of squares is greater than the sum, well, the sum of the products squared. Okay, so it's a little ugly to say. I don't like saying it, but it's essentially something like this. We do this. Okay, take a look at it carefully. So basically over here, we've got A and B. They're two separate lists of numbers, I guess you could say. And we're basically just going to square each of the components in them, square them for each of them, and then multiply that together. And we know that's always greater than or equal to the product of each of them squared. Okay, and there are actually ways to connect this to lots of other interesting ideas like vectors. But over here, we're going to focus on this question. So what do we do with this, right? This is called Cauchy-Schwarz. Okay, something like that. My spelling isn't the best, but let's go back to what we had above, and we actually don't have that much, but let's look at it anyway. So we had the square root of 2a plus b, I think, plus 2b plus c plus the square root of 2c plus a. Now, if we make this like a1 and we make this a2 and this b2, then what do we get? Well, on the right hand side, we're going to have what we want, right? We want this over here. And also look at this. This is one thing to be very careful about. They're saying find the maximum possible value. So you want this quantity that you want to find the maximum of, you want this to be on the less than or equal to side, right? Because then you know it's always less than or equal to that. So the maximum it can be is exactly that, right? It's less than or equal to that. Equality case is going to be your maximum. So I'm sorry, hopefully you caught the mistake. This should obviously not be B2, this should be A3, right? Because we don't want to mix it up like that. Okay, now let's just put this in for now. So we'll just square all of these and we get 2a plus b plus 2b plus c. which we already said what this is, right? Just scroll up if you want or try it out on your own. But this is just going to be 1200. Okay, 1200. And then we multiply this by b1 squared plus b2 squared plus b3 squared. We know this is going to be greater than or equal to b1 times the square root of 2a plus b, blah blah blah, okay, squared. Looks fine, but we're still not there yet, right? We've got 1200 times this. What do we take for b1, b2, and b3? Like, that's not in the question. Are we missing some values, or can we come up with them on our own? Well, of course, we can come up with them on our own, right? As long as we stay consistent, we pick the same b1 here and on this side. So pause the video now, think carefully. Okay, so if this is your first time, it might be a little difficult, but keep trying at it. And if it's not your first time, hopefully you have some more familiarity. Pick b1, b2, and b3 sensibly, and tell me what you get. Okay, comment it down below before you continue. Okay, please do that. Pause the video, comment it down below. Okay, hopefully you unpause the video. Now, if you're still watching, please make sure to subscribe. Okay, it's been 6 minutes that you've been with me. Hopefully you haven't hated it too much. And if you haven't, just make sure to subscribe so that I get helped and you'll stay in touch. And I mean, you'll stay updated if I make more videos like this, which I do plan on doing. Okay, well, yeah, long story short, remember, you want exactly 2a plus b plus 2b plus c and plus 2c plus a, right? You don't want like 3, 4, and 6 over here. You just want 1, 1, and 1, right? So it's not written in front of you, but you know that it's 1. You know that this is 1. You know that this is 1. So we take b1 equals b2 equals b3 equals 1. Now what do we have? Now we've got 1200 times 1 squared plus 1 squared plus 1 squared is greater than or equal to our desired quantity. Now I'm not going to write out the whole thing again, so I'm going to call that x and I'm going to square it. We know now that yeah, I mean, it's the sum of radicals, so it's obviously going to be positive. So we can just take the square root, and it looks a little ugly. So let's just, what is this? This is 3. So we have 3600 is greater than or equal to x squared. Now, just because you've stayed with me now for over 7 minutes, I want to pause, let you finish off the question. There's only one step left, and then you need to make sure to answer the question, right? Don't write an inequality, just give the numerical answer. But yeah, finish off the question. All you have to do is take the square root. So 60 is greater than or equal to x squared. X, which means x equals 60 is the maximum. Okay, this is the maximum. And that's the answer to the question. So hopefully you got this. I don't know when you paused and when you joined the video to hear the rest of the explanation. If you paused all the way at the beginning and just jumped over here to check the answer, great job. Okay, definitely it wasn't an easy question, right? Took some time, took some thought, especially if it's the first time you're using this inequality, and maybe it was impossible if you haven't seen the inequality before. Unless you sit there and prove it somehow, which is really, kudos to you if you did that. But yeah, it wasn't an easy question. So if you did a great job, even if you weren't able to do it, don't worry about that, right? The main thing is just practicing and trying to come up with some of the steps on your own, or at least grappling with the question, thinking about it, and struggling with it. Even if you don't come up with a single correct step, sitting there and trying stuff is always going to help you, right? Because maybe there will be another question where the approach that you use helps you. You'll understand what worked for you, what didn't work for you, all of that stuff. And it's super, super useful, right? Like, don't be discouraged if you weren't able to do anything. Make sure to watch the solution though, right? Like I'm not doing this for watch hours, but maybe skip through, watch at 2x if you need to, but just make sure you see the steps and understand them. Pause and rewind if you're confused on something. But yeah, I think this is a pretty thorough explanation of what we did here. And if you have any questions, make sure to comment them down below and I'll try to help you out with that. But thanks so much for watching, and I'll see you in the next video. Bye bye.